Hello guys, my name is Arun and welcome to my channel. This series is a series of tutorials on Advanced Fortran programming. Now, in today's in this lecture, we'll be looking at one important concept called as the pure procedure concept, or else pure function or pure subroutines concept. Now, what does that mean? I'll give you guys a quick explanation. See, uh, we all saw in all the functions and subroutines that we use so far that functions and subroutines, they can they can do print statements. Okay, they can get values and print values. Yes, they can do a lot of input operations, output operations and all. And they can if you want, you can make a lot of changes to the global variables within some modules and within modules also. Yes. Now, what does a pure subroutine does is that this sub this this subroutine has a lot of constraints and restrictions to it. Now, the why certain considerations, because if these constraints are put into it, okay, then the subroutine or the function becomes more easy to handle, very much easy to handle, and it gives a lot of optimizations while running the function or subroutine. Okay, now how to do that is simple. All you have to do is just write the keyword pure in front of it. Okay, now I'll you might not be understanding what and all is going on over here. Okay, I'll walk you guys through. uh, I'm using the same factorial function over here. Sorry guys, guys might be thinking that why is this guy just using factorial all the time for all his explanations for the past 3 lectures and all. Okay, but it's easy. Factorial functions are very easy, because it does a lot of operations, and it's kind of easy to operate, and it makes it's also useful because if you want to have a return, you want to have a different return name variable instead of the actual function name and all, it makes a lot of sense. That's why. Okay, what I did here is that I've defined a parameter parameter value n, which is equal to 10. You can set it to 20 also, and then I define an integer of kind 8 of value I, and then I've set two 1D arrays of dimension 10, since n equals 10. Okay, so namely num and numfax. Num will have a set of numbers from 1 to n, and numfax will have the factorial of these numbers correspondingly. And then I'm using this external keyword to denote to indicate to the program that we'll be using an external function called as fact underscore num. Okay, here using a simplified one line assignment. Okay, using some array operation features and all, I'm setting all the values of num to the values of num from base equal to their indices. So this num matrix from which ranges from num array from which ranges from 1 to n is set to 1 to n accordingly, using this I variable. Similarly, what I'm doing here is that I'm setting the numfax from 1 to n equal to the factorial of the number in the factorial of the number with index I, from the num matrix num array over here with index I. So this will return the 1 factorial, 2 factorial, 3 factorial, and so on up to n factorial, and all these n values will be allocated accordingly based on the index in the numfax matrix. Okay, we guys saw this in one of our previous tutorials, that too in the basic Fortran program tutorials. Okay, have a look at that. And what I'm doing is that I'm just using a do loop to print the matrices here, the each and every matrix here. Okay, and in here I'm using a pure factorial function. Okay, to do all the job. What I'm doing is that I'm getting the value, the number here. I'm setting an integer I, and then I'm setting fact to be 1. Okay, the function name is fact underscore num, but it's going to return an entirely different result, which result with the variable fact. Okay, it's going to return that with fact. Simple as that. Okay, because this will be using again and again and again, and so on and so forth. Okay, now or else what you can do is just you know an alternate procedure, whichever you can. What you can do is that you can do like this. You can write fact here and so comment this keyword out. Fact num equals fact. Okay, if I were to do this, this again works fine, but there is a thing. If I were to comment this out, if I were to comment this part of the function out, if I were to write this as fact underscore num, okay, num, if I were to run this, this will throw me some lot of error because fact underscore num is undefined kind of stuff, and if you cannot use the same function variable itself to do the same job and all, so it's kind of messy. So the better thing to do is that saved in a separate variable, thereby thereby your job is simplified much. Okay, this will do. Okay, you'll okay, fine. Now how does this pure function different from other functions? Now watch. Now I run this program, okay, compile, build this and execute this. Okay, sorry, it prints that 1 factorial is 1, 2 factorial is 2, up to like that, and so on up to the 10 factorial is 10. Fine. Suppose if I were to type this as 20, okay, compile build and execute, yeah, nice, yeah, perfect. It prints all the values up to 20 factorial nicely. Okay, let this 20 be there. Now what I do is that, suppose if I were to use a print statement inside this and compile this, it will throw me an error stating that print statement is not allowed within a pure procedure. Okay, now so when I comment this out, but when I compile this again, it works fine. Now this is one of the restrictions in pure functions and pure subroutines. Let me list them all here. Okay, there are a few things. First, rules for pure functions and pure subroutines. Okay, first rule is that all optional / dummy arguments must be of type intent in. Okay, so this is one rule. Second, what happens is that what it shows is that all intent in variables should not be be accidentally modified. Most of the time, even when a value is modified something, it won't throw an error. But watch, suppose if I were to write here num equals num plus 1, and then write num equals num minus 1, essentially even after modification it works fine, but it will just throw an error stating that the dummy because we gave it as intent in, you cannot modify it. You just cannot modify it. Okay, but if it's a pure function, again you cannot modify it. Okay, Now some some compilers, I think it will just show these as warnings, but it will not make the modification. But anyway, the intent in variable should not be accidentally modified at any chance, and no save attribute. That's the third rule. No save attribute. None of the variables should have a save attribute with them. Okay, this is another restriction. Okay, if you are using save attribute, then this function you cannot use the pure attribute to it. So this is something important. Okay, and this during even initialization, these functions, okay, no save attribute, no save attribute inside the function or subroutine. Okay, and next rule is that subroutine function should not handle global variables in the function or subroutine should not handle global variables and save variables. Okay, this is another condition. You have to keep in mind. The subroutine or function that we're using should not handle global variables and save variables. Okay, and the next condition, boy, I know there's a lot of there are like, I don't know, there are like a lot of conditions over here, and then let's see if I can remember properly. If this procedure should call only pure procedures, meaning here what I mean by procedure is it's the same. Just a note, procedure applies to functions or subroutines because it's a set of instructions or a procedure that you have to do. That's what you're doing in a function or subroutine. So if you are using if you're using a pure function or a pure subroutine, it can call only other pure functions or other subroutines. So if you have a recursive subroutine as a recursive function, okay, and if you want to call itself, then if you have defined it as to pure, you can't do it. And if you're using a pure function, okay, and it can call only other functions which are pure. You cannot call but if you don't define it as pure, that's okay, but it might work its way around. But if you're using a pure keyword, then if any of the above conditions are not followed, then those you cannot call those functions or subroutines inside. And probably the last and the most important rule is that no input and output operations inside procedures. Okay, now if you do not include any inputs and output operations like print statement or reading statements or write functions and all, if you're not including any of these, just intent in, intent out stuff, nothing more, nothing less, then then you can assign that function or a subroutine to be a pure value. Okay, now with these conditions into picture, now it works fine. Now if I were to write pure, now for this function pure applies, because first rule, all optional dummy arguments must be of intent in. Okay, since there aren't any optional arguments or something, so that's not whole good, but so you don't need, so this is not to be worried about. Okay, second, all intent in variables should not be accidentally modified. Now this is the only intent variable here and we're not modifying it anywhere, so no problem. Okay, now no save attribute inside this function subroutine. Okay, now let's just poke around and save I. Okay, if I compile this, it shows an error saying the save attribute at 1 cannot be specified in a pure procedure. Okay, so this very clearly says that you cannot have a save function, save variable inside a pure function. But if it's not pure, yes, save you can change I, no problem. Next, functions subroutines should not handle global variables and save variables. Okay, that it's not handling any of that stuff, so it's okay. This function is not handling, so it's okay, no problem. And then this procedure should call only other pure procedures. Well, as far as this goes by, it doesn't, but anyway, it's not doesn't matter. And finally, no input output operations inside procedures. And in this, I'm using this print function to do an output operation, whereas just display operation. Okay, if I were to compile this, it throws me a new error stating that print statement not allowed in it. Okay, let me get an input operation, read comma num. Okay, so I save this. It's an input output operation and it's not allowed. Okay, and finally one more stuff, write comma star num. Okay, even this is not allowed, so these things are not allowed. Okay, so suppose if we have a read function or something, or write function or print statement or any of these input output operations, you cannot use inside. If you're using these in a function or a subroutine, then you cannot make it pure. But if these are not available, it's better to use pure, because okay, why? Because these functions can be because these functions, when you use a print statement, read statement or write statement, okay, what happens is that when you use input operations or save attribute or write attribute or global variables and other stuff, and the compiler has to make a lot of relaxations on the function, so in terms of memory, in terms of stack size, in terms of in terms of optimization and all. So it has to allow a lot of it has to allow a lot of unoptimized works in the machine code running at the background to make adjustments to print the data, read the data and write the data, and all the saving the variables and all. Okay, these has to be done kind of unofficially or something when the function is not made pure. Okay, but when the function does not do any of the above mentioned jobs, okay, which if it obeys all the 6 rules it was mentioned on the top, then this function can be optimized. This function as subroutine can be optimized nicely. Okay, it doesn't matter if it's a recursive function, that doesn't matter, but it can be done nicely. Okay, so so no problem. If you were to use pure function, the function can be optimized very very nicely, so that it runs much faster. It kind of runs much faster and gives you little more results. At least maybe for this kind of a function, this kind of a program, you might not notice a big change, but maybe in a long-term process wherein you're working with a very complicated function and stuff, this will work nicely. Now, if I were to compile this, it works nice. Build this and execute this, perfect. What you have here is an entirely pure subroutine. Okay, and this is a pure function, and this keyword pure can be used to functions also, but is used to subroutines also, but in a similar manner. That's all. Well, that's all I have for you guys in this tutorial. And one more thing, pure subroutines and pure functions can be recursive also. So recursion is allowed, intent in-out operations are allowed, but intent out operations are allowed, but intent in operations are not allowed. Okay, so that's it. uh, that's it. So if I were to make a small correction over here, not a correction, just an extension, uh, however, uh, intent out and intent in out variables can be changed. Okay, however, intent in out and intent out and intent in out variables can be changed. Okay, this is kind of logical. If this is kind of logical, that's it. Thank you guys for watching, and I hope you guys learned something in this tutorial, and I'll see you guys next tutorial. Bye.